everyone. Okay, so I wanted to kind of give you a quick background on reducing radicals and putting them in their simplest form when it comes to things like, because we're about to start in our unit of um, uh, Pythagorean theorem, and I want to make sure you guys are able to reduce radicals and things like that too. So it's kind of important. We'll kind of build on this lesson, and we're going to start with some easy stuff, and then we'll go into variables, and then we'll go into dividing, adding, multiplying, and stuff like that. This is to give you some extra backup information from when you guys were, you know, you might have missed this stuff. And then I'm also going to spend some time on quadratics and factoring with you guys too as we approach the end of the year. So I started this out just by creating a page where I listed as many as I could, as many perfect squares and perfect cubes, because this is going to help me considerably when I go to reducing radicals. Okay, I'm going to show you a perfect foolproof method of not of when you don't have to know these, but the more you get to know these, the better off you're going to be. Okay, so definitely take a note card. You know, if you want to pause the video, take a note card, make a list of your perfect squares on one side and make a list of your perfect cubes on another. And keep that with you when we're doing things like radicals and stuff like that. The other thing I wanted to remind you of was what exactly prime numbers are. So prime numbers, I'm going to go ahead and type this up so it's easy for you guys to read because I know how my handwriting is. Prime numbers are numbers that only have factors of 1 and itself. Okay, let's list a few prime numbers. Okay, 2, 3, 5, 7, 11, 13, 17, 19. Okay, that's all you need for right now, just for this particular thing. And I need you guys to know how to factor this out. So the other type of numbers that we talk about are called composite. They're numbers like 9, because 9 has factors 1 and 9, and also 3. Um, 6, 4, all that stuff, okay? But as you can see, if you factor these out, the only factors for these are 1 in itself, okay? 1 is neither prime nor composite, so don't put that in either one of those categories, okay? So let's talk about radicals. What do we know about them? Well, it's important that you know the vocabulary when it comes to this stuff. So your nth root, the root, which is usually denoted right here, is called the index, okay? Now, when we do not have an index listed, but we have a radical sign, we assume that that is asking for the square root. And this is called a radicand. Not that you really need to know that, but it does come up. So if there's no index, assume that it's a 2. So we're going to basically start out looking at all these basic square roots. Now, I can do these in my calculator or in my head, but I'm going to show you a little bit of both, and we'll go from there. Okay, so we're going to go ahead and, sorry. Okay, so we're going to go ahead and take the square root of each one of these. So this is 4. So as we can see right here, why is this thing not cooperating? I apologize. So square root of 16 is 4. Now also be mindful that when you do any even root, there's usually a positive and negative root. So it's really plus or minus 4. So when you get into algebra 2, you're going to be dealing with the positive and negative roots. But while we're in geometry, we're only dealing with the principal or the positive square root. Now, the square root of 121 is 11. So we're going to do 2 times 11 because we're going to multiply this 2 by that square root and we're going to get 22. Now, square root of 289, you can always put that into your calculator. Again, I strongly suggest that you guys do invest in a TI calculator if you're going to Colgan, and that you keep it at home. We will, and under most circumstances, we would use the TI in class and we would have a class set, but of course I don't have that at under this situation right now. So the square root of 289 is 17. So I take 6 times 17. So 6 times 17 is 102. So that's going to be 102. And then 3 times 400. So the square root of 400 is 20. So that's going to be 3 times 20, which is equal to 60. Okay? So real easy when we have perfect squares. But what happens when we don't have perfect squares? Now, the reason why we want to simplify them is if you take a square root of a non-perfect square, it's what we call an irrational number because it's a non-repeating, non-terminating decimal. And just like pi, it's very difficult to actually express accurately, so we usually put things in radical form. Just as you'll notice as we get further on in geometry and also when you go to Algebra 2 and to trig, that instead of using 3.14 for pi, we just use pi, we leave things what we call in terms of pi, which means we treat pi like a variable because it's the most accurate way to do so. Okay, so what I'm going to do is I'm going to take you through some of these. Some of them I'm going to do the prime factorization method, and some of them I'm going to do factoring out the perfect square. Now, as you get better and better at recognizing your perfect squares, you are going to most likely prefer factoring out perfect squares because it is easier and quicker to do. However, when you get to fourth roots and fifth roots and things like that, you're going to have to do prime factorization. So it's important to know both skills. Okay, so when we're doing the square root of 32, I know that the square root of 32 is equal to the square root of 16 times the square root of 2. Okay, so what's the square root of 16? That's 4. So that becomes 4 times the square root of 2. All right, now what about 180? Well, I know 180 is equal to 36 times 5. So the square root of 36 is 6, and this is 5. Now, again, most people aren't going to know right off the top of their head that 36 divides evenly into it. So one of the things that you might want to do is actually do the prime factorization. So I'm going to show you an example of prime factorization, and we're going to go through that. So if I have the square root of 180, so again, when I take this, I'm going to divide it by one of my prime numbers. Well, because it ends in a 0, I know it's divisible by 5. So I'm going to do 180 divided by 5, and that's 36, right? Now, let's say we didn't recognize that this was a perfect square, right? So I'm going to divide this by 3 now. So this is 3 times 12. And that becomes 3 times 4, which then becomes 2 times 2. And I know when to stop because I only have prime numbers, okay? And I would strongly suggest you not divide by anything else. Please keep it prime, okay? So since this is the square root, we have an index of 2, so we're looking for pairs of 2. So the way I describe this is, hey, this is a house. We're all having a party in here, and you can only leave if you're in a group of 2, all right? So these guys are in a group of 2, so they go in a 2-car. Well, when they leave, they go in 1 car, so there's only 1 2 on the outside. Then there's a 3, 2 3s right here, okay? So they're going to go in a 3-car. So anything I take out, I multiply, and anything I leave in, I multiply too. Now, what I mean by leave in is this guy doesn't have any friends, right? So this guy is in the house, stays in the house for the evening. So that now simplifies to 6 times the square root of 5. Okay? Now, sometimes by dividing by a prime number, you can find that there's a perfect square in there, like I did right here. So you can stop right there if you wish, but it's up to you. Now here I have 147. Now I know 147 is divisible by 7, so let's go ahead and factor that out, all right? So that's 7 times 21. Well, I know 7 goes into 21 as well, so that's 7 times 3. And what do you know? I'm all the way down to prime numbers here. So I have 1 pair that goes in the 7 car, and he's on the outside. This 3 stays in the house. So it's 7 times the square root of 3. Okay? Now, I've also got 175 here. So I'm going to go ahead and divide 175. I'm pretty darn sure that 25 goes into that. I'm right. So that is the square root of 25 times the square root of 7. All right. So what's the square root of 25? That's 5. So that's 5 times the square root of 7. So there you go. All right. So when I can do this easily, I'm going to do my perfect squares. And then as I get further on, I'm going to keep trying to do my prime factorization. When I get to cube roots, that's going to be probably the easiest way to deal with it, because knowing a lot of cube roots is just hard to do. So the square root of 48 is equal to the square root of 16 times the square root of 3. Now, some of this stuff, as you do this more and more, and you're going to hate me for saying this, but as you do it more and more, it's going to get easier for you, okay? You're going to start to recognize, oh, well, 48, that's divisible by 16, so is 32, okay? Things like that. Anything divisible by 25 here. So that makes life a little bit easier. So it's just going to take time, okay? So this is 4 times the square root of 3. So when you have these, it's pretty easy. Now I have a number on the outside, so I'm going to keep that here. And I know that 54 is equal to 9 times 6. Now 6 isn't prime, but its only 2 factors are 3 and 2, which are prime. So I know I can't reduce this any further than I have. So this is 2 times 3 times the square root of 6. So this will be 6 times the square root of 6. Okay, moving on. So now we have some more here. So I've got 150. So what I'm going to do, 25 probably is a perfect square that goes into that, so let's go ahead and try that. So 150 divided by 25, just making sure that, yep, that's 6 as well. So this becomes -5, so you still keep that, and then I multiply that times the square root of 25 times the square root of 6. And again, you're going to also learn that 6 is, even though it's not prime, we can't factor it out anymore. So we're going to leave it like that. So we have -5 times 5 times the square root of 6. So that's -25 times the square root of 6. Now let's look at 128. So it's an even number, so I'm gonna go ahead and factor it out. So I'm gonna start up here just so I have some more room. So I've got 128, oh, well, I know that actually this is, if I divide it by 2, it's divisible by 2 by 64. Now 64 is a perfect square. So I'm gonna say, okay, 8 times the square root of 64 times the square root of 2, so that's 8 times 8 times the square root of 2. So that's 64 times the square root of 2. Okay, so square root of 28. So I'm going to just go ahead and take that out. So I'm going to divide it by 2. So that's 2 times 14. And that is 2 times 7. So here's my prime factorization. So I have one pair, and that's a 2, and they're going to go in the 2 card. But I have this -3 out here already, so I have to do -3 times 2 times the square root of 7. So that's going to be -6 times the square root of 7. Now, if I look at 384, that's a funky one. So let's see. 3. I know it's divisible by 3 because if I add up all these digits, 3 plus 8 plus 4, that's 15. And 15 is divisible by 3. So if I do 384 divided by 3, I get 128. So let's go ahead and do this. So don't forget about this 4, but we're going to just try to simplify 384. So that's 3 times 128. And then I know that's divisible by 2. So that is 2 times 64. Now again, if you get to this and you recognize that this is a perfect square, then good for you, right? Hey guys, sorry about that. That was brought to you by my pit bull Stella. So she's a rescue. She sounds vicious, but she's actually very sweet. But she'll scare the crap out of you when she barks like that. So anyways, I'm sorry about that. Okay, so this is 64. So again, that square root is 8. So we're going to do, sorry, 4. This is not cooperating. So this is going to be 4 times the square root of 64 times the square root of 6, right? So that's going to be 4 times 8 times the square root of 6. So that's 32 times the square root of 6. And there you go. Okay. All right. So now we also talked about cube roots, and those are also listed. So definitely make sure you have a list of them. So the cube root of 8 is 2. And the cube root of 343 is 2 is 7. So this is going to be 5 times 7, which is 35. Now remember, you can have a negative cube root. So it's either positive or negative. You can't have both. So this is going to be negative 3. Okay. And then this is going to be 2 times negative 10, which is negative 20. All right. So I'm going to take you through some of these cube roots. And then what we'll do is we'll go on to this next page is what you're going to have to do, simplifying radicals day 1. There's like 18 problems. So give you guys some good practice, and then I'll give you a solution set to it as well. So, okay, so here we have the cube root of 40. So right now, I know a perfect cube that goes into there. That's the cube root of 8, right? So this will be the cube root of 8 times the cube root of 5. And the cube root of 8 is just 2. So it's 2 times the cube root of 5. Remember, if we're doing cube roots, we have to put that little 3 there, okay? So the cube root of 192. Now this is where it kind of gets funky because you don't know every cube root. You're not going to, right? So we're going to go ahead and do prime factorization for 192, okay? So it's 192. I'm going to divide it by 2, so that's 2. 192 divided by 2 is 96, so 2 times 96. And then I'm going to divide it by 2 again. It's 2 times 48. And 2 times 24. And then I'm going to go ahead and move this over here. I'm sorry, guys. So we have 192. I'm going to actually move this over here. Okay, so I have 192, which is 2 times 96, 2 times 48, 2 times 24, 2 times 12, 2 times 6, and 2 times 3. So again, remember, we're looking for sets of 3, okay? So I have 3 2s right here. Oops. So that's one group. So that's going to go in a 2 car out here. And then I have another set right here. So that's another 2. And then this 3 stays in the house. So that's times the cube root of 3. So it's 4 times the cube root of 3. So let's look at 432. So that's 7, 8, 9. So we're going to go ahead and divide it by 3 first. So I'm going to take 432. So that's 144. So that's 3 times 144. Now this is not, we're not looking for perfect squares now. We're looking for perfect cubes. So we're going to divide that by 2. So that's 2 times 72, which is 2 times 36. 2 times 18, 2 times 9, and that's 3 times 3. So if we look right here, okay, normally I like to get all my 3's together. So let's kind of go back a little bit just to make life a little bit easier on us. So we still have that 2 on the outside, right? So we have 432. And we divide that by 3, and that's 1 by 1 and 44. So 3 times 144. And then I'm going to divide 144 divided by 3, which is 48. So that's 3 times 48, which kind of helps too because we're making this smaller quicker. We're going to divide it by 3. So that's 3 times 16, which is 2 times 8, 2 times 4, and 2 times 2. Okay, so we have a set of 3's right here, and we already have a 2 on the outside. So we have 2 times 3, and then we have another set of 2's right here. So that's another 2. And don't forget this 2 right here. So that's under the cube root of 2. So that's 6 times 2, which is 12 times the cube root of 2. All right. Now, do me a favor. Anytime you see a negative out in here, just bring out a -1. Okay. So I'm going to make this, that's equal to -1 times -2 times the cube root of 250. Okay. So that's 2 times the cube root of 250. So remember, 250 is equal to 2 times the cube root of 125 times the cube root of 2. So the cube root of 125 is 5. So that's 10 times the cube root of 2. Let's do the same with this 96 here. So I'm going to take a -1 out here. So I'm going to have -1 times 8. And the cube root of 96, let's see, 96 is divisible by 3. And that's 32. Okay, so that is, let's do 96. So 96 is 3 times 32, which is 2 times 16, which is 2 times 8, 2 times 4, and 2 times 2. So there is 1, 2, 3 2's right here. So that's -8 times 2. And then I have a 3, a 2, and another 3. So that's times the cube root. So that's -16 times the cube root of 6, 18. Now let's do 189. So we've got cube root of 189. So 189 I know is divisible by 3. So 189 is 3 times 63, which is 3 times 21, which is 3 times 7. So I have -3 because that's right here. And then I'm taking out another 3 times the cube root of 7. So that's -9 times the cube root of 7. Okay, so what I want you guys to do after this is use this as a guide and try to attempt the problems on this next page. It's the Simplifying Radicals Day 1 packet. So hopefully you guys are comfortable with that. Um, and then we will move on to square roots with variables and stuff like that, but we're not going to do that today. So that's the first part of your asynchronous assignment, just to help fill in some of the algebra holes that you might have due to our lovely friend COVID-19. So thank you very much for watching, and I'll talk to you guys later.